Now, let's look at nutrient concentration. Just a reminder that nutrients are vital to our ecosystem, but too much causes problems. It's important to distinguish this indicator, concentration, from loading, which was discussed in a different presentation. Loading is a measurement of how much nitrogen goes into our estuary. Nitrogen concentration, on the other hand, is a snapshot of how much nitrogen is available from the water column at a given moment. It's important to point out you can't always use concentration as a proxy for nitrogen loading. In some estuaries, the relationship between loading and concentrations is linear, but in many, the curve starts to flatten out. And that's because loading measures what goes into the system. Concentration measures what's left in the water column after much of the nitrogen has been processed. As shown in this figure, you see that some nitrogen goes into the atmosphere, some goes into the eelgrass, the seaweed, and the phytoplankton, some goes into the sediments and can be regenerated by microbial activity. Until you've quantified all those other components, you can't really assume that concentrations in the water are showing the whole nitrogen picture. As we begin to collect more data on these different compartments of where nitrogen can go, then this indicator will improve in value. So let's take a look at dissolved inorganic nitrogen, or DIN, at Adams Point going back to the mid-1970s. Since this is the first box and whiskers graph in this presentation, let me take a second to explain how these graphs work. The boxes encompass the middle 50% of the data points, from 25% to 75%. The horizontal line in each box is the median, and the upper and lower vertical lines show the complete range of the data. What you see in this graph is that the values over the last few years are beginning to resemble what we had in the 70s. That is encouraging, but we still need to know how much the nitrogen story has changed in the other compartments, sediments, plants, and algae.